Welcome, everyone. I'm so glad that you could join us for tonight's Tech Topics. And thank you, Vivian, for joining me tonight. Vivian's going to be keeping an eye on that questions box for us, so get those questions in while we're going. My name is Lisa. I'm with the Tampa-Hillsborough County Public Library, and we are going to be talking about 3D printing today. So we've covered this topic here and there before, different aspects of it. So for today, we're going to kind of give you a real broad overview of what it is and how it works and the different types of 3D printing that are available commercially and for home printing or library printing. So we'll go over all that. We'll go over some of the different software that is used to create the designs, and then some of the actual 3D printer models, and like the ones that we have at the library, we'll go over a little bit of that. So we'll kind of do this as a fairly high-level overview, give you a broad overview of the topic, but then I'll point you at some resources and some library programs that we'll have coming up that we'll get into a little bit more detail on specific aspects of it. So with that intro out of the way, let me pop on over to our next slide. So, yep, like I said, here are our main topics for the day. We're going to go over what they are, how they work, how they're used, and some features to look out for. So we'll jump right in with what are 3D printers. It's all in the name. So this is something that takes a digital design and converts it into a 3D or a physical object. So we're going from digital to physical here. So a computer file with bits into a tangible 3D object. 3D printing in general is considered an additive process. So additive, also right there in the name, we are adding materials and creating layers and layers to build something new. There are a very few type of 3D printing processes that involve lasering away material, which would be a subtractive process, but those are not super common that you would encounter. So we're not really going to go into those at all, really. We're going to focus on the additive process 3D printings, and we'll go over the different types of that as well. Some common 3D printed material, so what you would use to print, so your ink, if you will. The most common is going to be plastics. So different types of plastics are generally used for most home 3D printers or consumer grade 3D printers. Some of your more industrial applications will have different kinds of plastics. So for your home, you'll probably mostly encounter PLA type plastics. For industry, you might get something that's more specialized, get more nylon and other kinds of polymer products. There are also 3D printers that can print metal. We'll go into some neat examples of that as well, or even concrete. You can 3D print a house with concrete nowadays. So those are the common materials that you will hear talked about, but they're not necessarily common in terms of they're accessible to us. For that, it's generally going to be plastics or polymers, but metals and concrete are popular and growing uses for 3D printers. So going over the three main types of additive 3D printers, you're going to have your FFF. So that is not a failing grade, that is a fused filament fabrication. Say that 3 times fast. So this is going to be the most common kind of 3D printing, and it is also the kind of 3D printer that you'll encounter in our library programs. It's going to extrude a material. So extrude, that just means that it's pushing something out of something. It's going to extrude a material, and in this case, it's typically a plastic filament. So you'll see a spool of, it looks like plastic spaghetti almost, wrapped around a spool, and that pulls it through, heats it up, and pushes it out of a nozzle. So that it's kind of like, if you think of hot glue coming out of a hot glue gun, it's going to look very similar to that. You're going to have a melted thing coming out of a nozzle. Another kind is SLA, or stereolithography. This one's really interesting because this one is a liquid goo, basically. You're going to have a liquid resin that is a kind of resin that can be hardened by UV light. And you have a container with this liquid resin inside of it, and the build platform is put inside of that container of liquid. And it'll typically have a glass bottom or a glass wall that they shine a laser through, and that laser will be using UV light as its beam. So as that UV enters that container through the glass, it's going to hit the plate and build up layers by hardening that resin where the laser beam hits. And that usually they'll have it where the platform rises up within that liquid and builds up the layers that way. So that's a really neat one because we're shooting lasers into goo. I mean, that's the future. Another one that shoots lasers around, we have our SLS, or selective laser sintering. Now, this is a very fun one if you are into NASA and space technology. This is one that they've been for years prototyping, working on for the space station. So with SLS, or selective laser sintering, you have a container of a powdered material. And it can be a powdered polymer or plastic, or it can be a powdered metal. So think of, really fine aluminum powder, or even titanium in some cases. So a very, very, very fine powdered material in this container, and it will shoot a laser into that material. And as it hardens in that area, it'll then have a wiper that comes across and brushes away the material that wasn't lasered. So you've got your container of powder, you shoot your design onto it, wipe away what you didn't laser, put more powder on top of it, laser it, and you build up your layers that way. But this is a way that you can 3D build metal parts. So if you're up on the space station, or if you're on a crewed mission to Mars, you're that first astronaut heading to explore the solar system, there's only so many spare parts you can take along with you, but you might be able to take a giant container of powdered metals, powdered plastics. If you have your 3D printer on board, if you need a part, you could just print it on the spot. So that's a really, really amazing advantage that we're going to have moving forward with being able to 3D print things in space. So I've gotten to see some of the tests from that, and it looks really, really neat. So that's an exciting development. But those are our three main types of 3D printing that we'll look at. Like I said, there are, for very, very specialized purposes, there are different kinds, including some of the subtractive processes. But these are the three main types that you'll encounter. So how do they work? Well, we went into a little bit about, some of them push plastic through a heated nozzle like a fancy hot glue gun, and some of them shoot lasers into things. But really what it boils down to is that you're taking a three-dimensional model, a digital model, and you're using that printer to make it a physical thing. So in our case, in library programs and most of the home printing applications, you'll have a software that, like Tinkercad or Blender, those are the two that we tend to use pretty often for our classes, where you can either design something from scratch, or a lot of times there will be designs that are already created by other users and other people who have come up with a tool or a replacement part, and they've uploaded their designs there, and you can either download theirs and use it as is, or you could download their file and then maybe modify it to fit what you wanted to do, or if you wanted to maybe use a different material or adjust it in some way. So you don't necessarily have to start from scratch with these designs when you're first getting started. It might be nice to choose someone else's design and start with that. Maybe the next time after that, choose a design and modify it and print it, and slowly work your way up to creating your own three-dimensional models. But these two programs that I have listed, Tinkercad and Blender, are fairly straightforward to use. There's a lot of free software options and free designs that are easily usable in there. Well, and then how do you get that design to the printer? That's going to depend on the specific model that you have. Some of them are where you could plug in, save your 3D printer file to a USB and plug it directly into the printer and print from there. And some of them you just attach your computer to it with like a USB cable. So kind of like you would connect a printer to your computer, sometimes you can do it wirelessly, sometimes you have to plug it in. It'll depend on the specific printer and the specific computer that you're using. Something else to consider is that the size of the object that you're going to print is only really limited by the size of the platform or the base plate, and then the amount of height that you have between the base plate and the highest point that your extruder nozzle can go. But that doesn't mean that you can't print things that are larger than your 3D printer. You would just have to sometimes maybe break your 3D design down into different parts and print the parts separately and then assemble it afterwards. So just remember, just because it looks like it's too big to fit in your printer doesn't mean you can't do it. You just have to do it in smaller projects. Some other things to look for when you're maybe looking to get started on this is that you want to look for material compatibility. So what kinds of things do you want to print? Do you want to print mostly stuff just for fun? Maybe some 3D models for tabletop games, or maybe some replacement parts for things around the house. In those cases, you can go with pretty much any kind of filament or material. But if you're going to be making something that you might want to serve food in or store beverages in, you would want to make sure that you're using a food grade plastic for that. So always check your material on the spool when you get it to make sure that it's going to be a safe material for you to use for what you want to use it for. Something to look for in terms of if you're thinking about maybe buying this. First thing I would say is make sure that it's something that you want to do. So it's a great time to maybe try it out first. Sign up for a library program that's using it and try it out that way. Maybe try out a friend's for a while to kind of get comfortable with the technology and see if that's something that you want to get into, or if it's maybe something that maybe you don't want to buy, maybe you just rather use it once in a while as you need it. But if you do look to buy it, we talked about, the biggest limiter is going to be the size of your plate and the height between the nozzle and the plate. So keep that in mind. If you're going to be doing a lot of very large projects, you're going to want to get something that has a little bit more wiggle room. And if you're buying the materials for it, like I said, make sure you have the right material for the job. If you're going to be doing something for food, make sure it's food grade. Filaments are pretty easy to get. They're fairly inexpensive, and you can get them in a bazillion different colors and sparkles and whatever you would like. So just check out, make sure that the gauge or the size of filament that you're using is going to fit with your printer. They're all fairly standard, so I would be surprised if you ran into any roadblocks there. And here's a quick look at the two primary kinds that the library has. So most of our branches will have one of these for 3D printing programs. And these are the two types that we have. We have the Lulzbot Mini 2 and the Lulzbot Taz Workhorse. So the Workhorse is a little bit of a larger one. It can take a direct USB stick to upload a file and print directly from that, whereas our Mini 2 is a little bit more of a simple machine, and that one you would need to plug in directly to the computer to send your design. But they both work essentially in a very similar way. So the Workhorse can let you do somewhat larger pieces. The Mini does mini pieces. But we have those at many of our branches, so check that out. And if you're getting started on the, hey, I need to come up with a design before I want to print it, we do have a lot of classes available. Especially through the LinkedIn Learning platform, there are a ton of different classes that can get you started in terms of the graphic element, creating that 3D rendering, using that software to make the file to create that design. And then there's various classes on the actual 3D printing process itself. So check those out, hcplc.org/online classes. Scroll down, tap on LinkedIn Learning, log in with your library card, tons and tons of options to get you started. But if you're signing up for one of the library classes on 3D printing or one of the makerspace orientations, they got you. They will get you started. You can walk in there with having no experience whatsoever just to get started on that. So no worries if you're learning it through a library program, but I always like to be a little bit prepared before I go in. So I'm not starting from scratch. So if you're like me, you might want to check out some of those classes first. Speaking of our maker spaces, I always have to plug our super fun library maker spaces. We have not just 3D printers, we have sewing machines and desktop cutters like the Cameos and Cricuts. One of our branches even has a laser cutting, laser engraving device. There are collaborative workspaces, so if you want to learn how to make something, get that hands-on experience, the library hives are a great place to start. If you go to hcplc.org/hive, that'll point you in the right direction if you're interested in any of these, either to get into the space and sign up for an orientation class, or if you're looking for more of those online classes and tutorials, they'll point you in the right direction for those as well. So yeah, hcplc.org/hive. Ooh, that was a whirlwind tour. So I've got our Q&A slide up. I've got our contact information in the background. So what did you think, Vivian? Are you ready to get started with some 3D printing?
I am. I really need to take a class. This seems so cool.
So I'll show off this little friend here. So I was over at the Seminole Heights branch earlier today to help them out with a theater program that they had. And one of the staff was doing an orientation for one of our newer staff members and showing him how the 3D printer works and how that gets set up. And they had this little friend-shaped 3D printed object that they had worked on at some point. So this is just a cute little example piece of one of the things that you could 3D print. Now you see how it's all linked together and it moves. Those pieces were printed like that. So this isn't something where we printed each piece separately and put it together. It was 3D printed to already be linked. How fun is that?
Very cool.
So yes, it's a friend-shaped friend.
So
looks like
Lisa,
we have some questions coming in.
Yeah, we do. And out of curiosity, how long would it take to print something like that?
It depends on the printer. It depends on a lot of things. Sometimes it can vary depending on what density you're printing or what type of filament you're using. It's be honest, it's a relatively slow process. So it's not like an inkjet ink printer where it's and it's done. So, something like this would be relatively short, probably less than an hour. But anything more complicated, add the complexity, add the layers, add the density, and the time goes up from there. So yeah, that is something to keep in mind. This is not a fast process. So if there's, for example, if there's a class that you're working on an activity in the class, a lot of times you'll save your file and give it to the staff member who's teaching the class. And a lot of times they'll print it after you've gone and then set a time for you to come back and pick up the finished project afterwards. So if you think that each piece, takes up to an hour to print, well, if we have, 5-10 people in the class, we couldn't do that during the class. So yeah, a lot of times if there's a 3D printed class, you'll work on your file in the class and save it to the USB drive, hand that over to the staff member, and then they'll print it for you and let you know when it's ready to pick up.
Cool. All right. So one of the questions that we have that came in says, do you offer any classes for teenagers interested in learning as well as hands-on training?
Yes. So our classes are typically open for, especially for the Makerspace classes, they're going to typically be open for adults and teens. There's rarely a specific age restriction on this kind of class. With these, if it's anybody younger than a teen, we would probably ask a parent to be there with the child. But for teens, I would see no reason that they couldn't sign up for one of these classes.
Okay. One of the other questions is there a cost for the material being used, filament, or for the laser printer?
So if it's a library program, it's free. So these are, if it's within the context of a class that we're teaching, any material that's used in that class is going to be free and part of the experience. If it's an open makerspace type thing where you book a time to use the space, you would probably need to bring your own material for that. But if it's anything within the context of a class, it's all covered.
Okay. It's even better. Another question is there any assistance on intro to holograms? It looks like their high-functioning autistic nephew appears to learn 3D printing and hopes to create a hologram. So they're looking for a resource and helping them to get hands-on access to learning this.
Well, we're looking at two different technologies here. So the 3D printing is where we're making a physical object. Whereas with the holograms, we do have some virtual programs on like augmented reality, but a hologram is a light projection. So that's like a projector that you would have at the movie theater, except it's going to project it with many more lasers and lights to make it appear to be a three-dimensional object, when in reality, it's a three-dimensional projection of light. So it's two different technologies. What we're talking about today is 3D printing of physical objects. Holograms are not something that we're set up to do. That's a little bit beyond our technological ability with the library, but we do have some virtual classes on augmented reality. So where we use our phones or like Google Glass to have an augmented or a virtual reality experience using a smartphone.
Okay. And then another question is, are there any limitations as far as the materials that can be used at the library's printers?
So you would, that would be part of your makerspace orientation. It's going to depend on the specific device that you're using in terms of which material would be the right one to use with that machine and for your project. So if it's within the class, they'll have the material already provided. If you're using the makerspace after doing your orientation, I would just talk with the branch staff ahead of time and let them know what you're wanting to work on and let them give you the guidance on your specific project that you're working on, plus their device to make sure that it's going to be compatible.
Okay. And it looks like this will be the last question. It says, when, where can they get info on the augmented reality classes?
Sure. So if you want, we did a tech topics on it. So if you go to hcplc.org/tech topics, that's our main page where we have all of these classes listed, and it has a link to our YouTube playlist. So probably the easiest way is going to be to go to that website or look through our YouTube playlist to find it that way. We've done a few different segments on different aspects of augmented reality on there, so you can find it easiest that way. Within those classes, when you watch those classes, we'll also there are usually links to other continuing education classes about that, whether it's digital classes or books through the library that you can get that has more information on that topic. Speaking of finding more information, if you go to hcplc.org/contact, that has a link to our Ask a Librarian tool. If you click on that during business hours, that links you up with one of our staff librarians here in Hillsborough County. So if there's ever anything like this where you're like, hey, they talked about, augmented reality in this class, and I can't remember where I go to find the information. If you just go to our Ask a Librarian, they will point you in the right direction. And even if it's not something that we've done a class on, they can point you in the right direction on where you can get more information on it, regardless of what the topic is. But yeah, if you want more programs coming up that are live, in branch or virtual, hcplc.org/events is your friend. So speaking of upcoming classes, our next one is going to look at our recording studios. So there are a handful of our branches and branch maker spaces that have full recording studios, and they're pretty amazing. So that's going to be our topic next month. I'm going to give you a look into a couple of those branches and give you a sneak peek behind the scenes on what it looks like in there, what kind of recording you can do, what kind of gear we have, and what kind of classes that we have either in the branch or online to get you rolling on that. So we'll get some more details on the recording studios next month.
Perfect. It'll be a good one too.
Yeah. All right, it looks like that's it for our classes, or for our questions. So thank you so much, everyone, for joining us. Thank you, Vivian, for helping out with those questions. I hope everyone had fun, and I hope to see you for our next class. We'll see you soon, friends. Bye.
Bye.